Hi, and thanks for tuning in to the CBA Podcast, a place where we chat about our own recent achievements in the area of electronics, software and mechanical engineering, and more likely than not, give excuses for not having done anything at all. This week we, or rather I, will be talking about the Commodore 64 adapter cartridge, stumbling blocks while making something, reasons for making something, a resistive load PCB, fixing Commodore 64s, and an old LED banner board. So this week is just gonna be me. Unfortunately Piotr didn't have time, had other stuff to do, but hopefully he'll be back next week. But because of modern technology we can emulate him, right Piotr?
Fine with me, everything is fine with me.
Okay, so you did anything today, or this week?
I found some cure for cancer.
Oh really?
Yeah, took me 1 hour.
Okay, that's pretty cool. Well, thanks for tuning in, and maybe see you next week. So, it just achieved a new level of lameness, but we'll see how it goes. First, so I'm going to just talk about what I did this week and last couple of days. That was a Commodore 64 adapter cartridge that I talked about previous episode already. Now the idea is to have a Commodore 64 with this cartridge adapter plugged into it, and into that cartridge adapter another game cartridge, for example, can be plugged. Now if you turn on the Commodore 64 it will display not the game cartridge but, for example, an advertisement screen or a logo or a club logo or something like that. Until you press space, then it disables itself and you would see the actual game cartridge plugged into it. So this is like a intro screen in hardware. You don't have to do anything for it. So previous time I laid out the PCB, received the PCB, and what I did now was assemble it. Yeah, I wanted to turn it on, but unfortunately it didn't work. And what didn't work was I couldn't get a serial signal out of it. And of course I couldn't get a serial signal out of it because I wired the UART pins of the microcontroller to nowhere basically, or to I/O. So they should be going out of the board, but they were going nowhere. And I did that because I reshuffled the pins. Initially I mapped pins to functions, then noticed that layouting or routing was really difficult, and I shuffled stuff around, so make the physical layout of the board had to make routing easier, right? Unfortunately didn't think long enough, and transmit pins ended up somewhere where they shouldn't be, transmit and receive, so now I cannot talk to it. So place some jumper wires, so that should be okay. Made some very simple software to blink some LEDs, test the I/O. So it only has one button and 4 LEDs, so it tested that. And that works. And now the main software should be written. Well, the PCB is basically a parallel flash and a microcontroller and a lot of buffers and multiplexers. So what the cartridge basically does is either connect the game cartridge plugged into it to the Commodore 64 or connect its own flash to the Commodore 64. So it can either run the contents of the game cartridge or itself. And it also controls reset lines to the Commodore 64 and monitors I/O lines coming out of the 64, and is basically connected to the address and data bus of the Commodore 64. So that's on a hiatus now because I'm doing other stuff. Yeah, just have to make that software at some point. Shouldn't be too hard. Right, talking of which, what I noticed here when I try to do something new is there's always some stumbling block that makes me postpone stuff. And most of the time it's the boring work of selecting components for a new project, because I don't like that. Then there's footprint and symbol drawing, I don't like that either. And I find that when I do that, when I select the components, draw the symbols, the schematic symbols, draw the footprints, then everything is pretty easy. So layout, schematic making is pretty easy, layouting is pretty easy, and that's it basically. The board is made very fast. So after that comes software, and because an assembled board is already pretty to look at, I tend to wait with the software too long. So I'm not that interested anymore in making software, although it's just a matter of one day or something like that. And that happens with hobby projects and work as well, when there's embedded software involved. Now, talk with Piotr already and other people about reasons for making something, and most of the stuff I make here is complete bullshit. So, for example, this Commodore 64 cartridge that's semi-useful, but most of the stuff I make here is, bullshit. So, for me, I do it just for fun, but some people, they look at me very strange when I try to explain that it's completely useless. So they'll look at me, give me a blank stare. Oh well. Another thing I did was I'm making a simple resistive load for 230 volt AC. So to test devices giving out 230 volts to see if the tracks and the relays and everything can handle it, and if there's no interference because of the high currents and so on. And this is still not very high, but I'm planning on making 2 boxes, each be able to dissipate 240 watts maximum. And to do this, I made one PCB holding 8 330 ohm resistors, all in series, so each resistor will be dissipating a little bit more than 2 watts. So each board at 230 volts AC will be dissipating about 20 watts. Now if you stack 12 of those in a box on top of each other using standoffs, you can dissipate 240 watts. Right. And what I want to do is always power on 5 boards for 100 watt. So the minimum load is 100 watt. And use 3 switches, like 3 bits, to turn on, for the least significant bit, turn on 1 extra board, so that's 20 watts. For the middle bit, turn on 2 extra boards, so that's 40 watt. And for the most significant bit, turn on 4 boards, so that's 80 watts. So you can switch, select between 100 and 240 watts and 20 watt increments. And I try to make 2 of these boxes. Yeah, that should work okay. The cases are normal small square PC cases, and with a transparent side cover. So I'm gonna laser cut holes in that to mount 1 switch to turn everything on, plus a fan blowing air through the stack of PCBs, so the heat can be to get rid of the heat, and 3 switches to select the level. I'm gonna make 2 of these boxes, so see how that goes. Probably never gonna use it, but I needed something like that in the past, so if such a situation arises again, so at least I'm prepared. So that was that. Yeah, just for fun, I went to, that's a semi-monthly event to fix gear, and especially fix Commodore 64s, so I like that. I like to do that with a bunch of people to get ideas and to see how they do stuff, and to gain some experience. This time was just me. Well, there was one, to go in a little bit more detail, one Commodore 64 had the problem that the drive wasn't working, communication to the drive wasn't working, so if you connect the 1541 drive, you wouldn't be able to load files and so on, so the Commodore 64 will be stuck forever. Now, what I did was measure the clock and the serial signals, the data signals of the Commodore 64. Commodore 64 uses an open collector driver, 7406 IC, to drive a signal low, and when the disk drive, floppy drive, in turn is driving the signal low, it will, drive it will drive its open collector output, so which goes to an input pin on the CIA chip on the Commodore 64. Now, I measured all the signals, everything looked fine, but it still didn't work. Replaced the CIA chip, swapped the CIA chip, problem still persisted, so then started getting a bit desperate because I didn't know what was going on. Started measuring with the oscilloscope the read and write signals. The ship select signal of the CIA, which looked also fine, and read and write signals coming out of the CPU, which looked like absolute crap. However, that was not the problem. Mental note, I still have to find out what was going on, because I don't understand that. I have to ask someone else what's going on there. But the problem turned out to be the open collector driver IC not being okay, so replaced that and everything worked fine. So that was nice. And that was it for the fixing. And just now, while cleaning up, found a very old, I think, well, from 1995 or something like that, 1 meter long LED matrix board of 24 7x5 LED matrix blocks behind red translucent plexiglass thing, so you can hang it in a store. Actually, I worked in a store where that board came from, because they sold me the board when the store stopped being a store. Always kept it there, tried to apply voltages. I didn't know which voltage it was, so I probably broke it. I wasn't too careful, I just wanted to toss it away, but I got a bit bored. But that didn't work, so open it up. There was 8031 processor inside, which is, I think, 8051 sort of processor, with an EEPROM for probably program memory and RAM for working RAM, and also backup battery, and serial port for programming. So I'm actually glad I disassembled the whole thing instead of trying to reverse engineering the serial protocol, because that takes a lot of time, and I'll probably desolder the LED blocks to make something, maybe, or give them away or toss them away or something like that. So that's basically it. I think the next week or something like that I'm gonna do the fixing stuff again. Hopefully Piotr will be back by then, maybe not, I don't care.
Fine with me, everything is fine with me.
Yeah, we'll see how this goes. I'm hoping this will be a co-hosted podcast, but yeah, we'll see how it goes. Oh, almost forgot. Also added a headphone adapter to a Game Boy SP, a Game Boy Advance SP that I got yesterday. And eventually what I would like to do is make some sound using it, using a Nano Loop 2 cartridge or Little Sound DJ or something like that. See how that goes, but unfortunately the Game Boy Advance SP didn't have a headphone output, so it was very easy. Open it up, make the thing think that you have a headphone connected by soldering some detect pin to ground and soldering a small cable to a 3.5mm socket to it, and make a small hole in the enclosure and close it up again, and that's it. So that's what I did. So that was all for now. For more information, links and previous episodes, visit podcast.cba.si. Stay tuned, thanks for listening, and goodbye.